Hello everyone, welcome to the last ATRA webinar for the year. Today's presentation is sponsored by Seal Aftermarket Products. Let me play you a short video from Seal Aftermarket.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, any questions or comments, please send your emails to webinars@atra.com, especially if you have any ideas of what you'd like to see for next year's webinars. Any questions during the webinar, feel free to text them to me, and I will answer those the best that I can. A couple of weeks away, Expo at the Rio, like last year in Las Vegas. Halloween weekend, it'll be October 29th through the 1st. And right after Expo, we have the last seminar of the year will be in Baltimore on November 7th. Today's presentation, we're going to talk a little bit about comparing the A960, A760, and the AB60 rear-wheel drive 6-speeds for the Toyota and Lexus vehicles. As you can see here, there's a wide variety of vehicles that this unit fits behind. Some European, some domestic. Normal rule of thumb for Toyota is always the higher the model number, the smaller the engine that it goes behind. As you can see here, the A960 goes behind the V6, where the A761 goes behind the V8. The AB60 is the largest of the 3 units. You'll find 2 ID tags on these units. You'll find a sticker on the left-hand side close to the bell housing, and then there'll be a metal plate that's riveted to the rear of the case on the right-hand side. Now, although this webinar is about 6-speed, I just wanted to quickly mention some differences between the later 6-speed models and the earlier 5-speed models. If you look at the cutaway views of an A650 or 750 5-speed, you'll see there's an addition of some clutch assemblies and solenoids between the 2 5-speeds. You'll also notice a major difference with the earlier 5-speeds is the exception of the rule for Toyota and Lexus models. As I mentioned before, the general rule is the higher the transmission model number is usually found behind the smaller engine and vice versa. And not the case for the 5-speeds. The A750 is found behind the Toyota Lexus models with the larger engine, whereas like the V8s, The lower model, like the A650, is found behind the smaller V6 and V8 engines. Unlike the 6-speeds, they do still follow the general rule. Here's the application chart for the 5 speeds. As you can see here, the 650 goes behind the V8, and the larger number goes behind the larger V8s. Now, although both units are 5 speeds, there are differences in how they work. For example, they both have 3 sprags, but they are named and work differently. The A650 has 5 brake clutches, whereas the 750 only has 4 brake clutches. They both have 3 driving clutches. Here's a comparison of the valve body and solenoid arrangement. As you can see, they are completely different, even though they both have 7 solenoids. The SL1 and the SL2 of the A750 had a change on the solenoid connector. It became smaller in design. Now we're showing you here the component apply charts to show how they work differently. For example, the F0 and the F2 sprag are holding in first gear on the 650. Although the difference here is the F3 sprag is holding in first gear on the 750. So you can see how they work quite differently. As far as the A760, the 960, or the AB60 6 speeds, all the drivetrains are the same. So this cutaway view gives you an example what all 3 are laid out like. They also all have 4 driving clutches, 4 brake clutches, and 4 one-way clutches. This illustration will give you the proper name for the solenoids. We're identifying the solenoids here. As you'll find in most of your repair manuals or aftermarket information, they list the solenoids as you see here. When you go to a parts catalog or you call the dealer, they're going to name it something different. So the S1 solenoid would be the solenoid assembly automatic transmission 3-way number 1. As you can see, the S1 and the S3 are the same, as well as the SL1 and the SL2 are also listed in the parts catalog as the same. The only difference here on the AB60, you'll have 2 separate wire harnesses, and we'll talk about that as we go along into the webinar. There's your solenoid apply chart for all 3 6 speeds. We found most of the internal components are basically the same in design. The AB60 is much larger than the other 2. Now, although the A960, the smallest of the 3, the C1 and C4 clutch drum is smaller, but the tip is a little bit longer than the other 2 units. Here's a layout of the internal components. As you can see, they're all the same. The only thing different will be the size of the components in comparison to which unit you're working with. Here are all the bell housing differences due to engine application. We've got the A760 and the 761 side by side. And then we have the AB60 to the right. As you can see, that's quite larger than the others. And then the smaller of the 3 different units is the A960. On the AB60, the internal harness, there is actually 2 of them, and it will also have 2 temp sensors. Now the case will have 2 holes, 1 for each of the case connectors. Now the smaller harness has 2 pins. The larger harness with the 2 temp sensors on it, it has 15 pins. The 2 temp sensors you hear are just like what you would find on an A750. The only difference is that will have 1 internal harness. So of course there's going to be 2 holes in the valve body for the dual temp sensors on the AB60. You have the temp sensor 1 and temp sensor 2. Now the temp sensor 1, which is the TH01, is the one found lower, closer to the manual valve. The TH02 is closer to the solenoids. Now the TH01 is used for hydraulic pressure control. This sensor is used to revise the applied pressure to the clutches and brakes so we can have a smooth shift quality. The TH02 is used as a basis for modifying the computer shift timing control when the ATF temperature is high. It's also used for the ATF temperature warning lamp. There's only one internal harness on both the A960 and 760 with one hole in the case for the connector. And that's also a 15-pin internal harness with one temp sensor. So in that case, the valve body will have one hole blocked. That'll be the one closer to the solenoid. And then you'll have one open hole for the temp sensor, the single temp sensor found on the internal wire harness. These temp sensor values max out about minus 40 degrees Fahrenheit to as high as 419 degrees Fahrenheit. Here's the 15-pin identification and specs for the one internal wire harness found on both the A760 and 960. As you can see here, we have the values for the temp sensor resistance as well as the resistance for the solenoids, and also identifying the solenoids whether they're normally high or normally low. Here's the pin ID for the two internal wire harnesses found on the AB60. As you can see, there's actually room here for 4 pins. There are 2 that are not in there, so you'll find only 2 pins in that connector. Those 2 pins go to the SL2 positive and negative side of the solenoid. They'll have 2 speed sensors. They're both permanent magnet AC pulse generators. They'll have a turbine speed sensor referred to as the NT that actually monitors the lugs on the C3 drum, while the output speed sensor, the SP2, monitors the part gear. As you can see, they're located on opposite sides of the case. The NT is closer to the bell housing on the right-hand side, while the SP2 is on the rear of the case on the left-hand side. Now, both these speed sensors, although they are AC pulse generators, they are polarity sensitive. In earlier days with AC pulse generators, you used to be able to hook up the wiring either way and they still work. In this case, they're actually polarity sensitive, so you have to make sure that if you are wiring up a new harness that you wire it up correctly. The NT produces about 0 to 3 volts AC, while the output speed sensors actually produces about 0 to 6 volts. Both sensor resistance are 560 to 680 ohms. The ECM uses this to control shift timing, also controls engine torque and hydraulic pressure. When the input speed sensor malfunctions, the shift control is affected by using the information from the output speed sensor. During the time that the input speed sensor malfunctions, up shifts to the 5th, 6th, and what they refer to as artificial intelligence, which is like sports mode, or flex lockup control will all be prohibited. Now, when the output speed sensor malfunctions, same thing happens. It just starts using the input speed signal. Now, when the output speed sensor malfunctions, same thing as the input speed. You lose the upshifts to 5th, 6th. The artificial intelligence shift or base shifting will not be used, as well as the flex lockup control. All of those will be prohibited. Now, flex lockup control happens during mid-speed range, low to mid-speed range. They flex the lockup control by regulating the lockup solenoid to give it kind of an intermediate mode between on and off operation. Now, they do this for more efficiency. This results in fuel economy and improved efficiency of the vehicle. Now, the flex lockup control operates in 3rd, 4th, and 6th gears in the drive position and S6 range. It also works in 3rd, 4th, and 5th gears in the S5 range, as well as 3rd and 4th in the S4 range. Now, when this vehicle is decelerating, that's with the accelerator pedal completely released, the flex lockup control still operates. So it's not unusual to see that the converter is being slipped at a certain rate during coast down. This expands the engine fuel cutoff and improves fuel economy. One of the things I want to point out when you remove these solenoids is you have to make sure that when you go back in with them that we align the retainer pin with the correct slot on the solenoid snout. We've had guys in the tech line actually install the solenoid part way and have the pin aligned with this snout. Obviously the solenoid is not going to work correctly. You'll find 4 of these pins underneath these 2 hold down plates that we're showing you here. Here's some valve body information for all 3 units. We have one screen, the opening facing up. This screen does not snap into the plate, but the open end faces towards the plate. Now there's no spring tension on this bore plug. It's laid out here in the middle of the valve body. A lot of times the retainer will become lost when you're blowing out the valve body cleaning it, so be careful not to lose that. You also have one check valve, as you can see, number 6. And the spring goes down inside the valve body first. There's another layout of the valve body. What I want to point out here is you can see we have these 2 check valves. There's no spring tension on this one either. So a lot of times during rebuild when we're cleaning out the valve body with shop air, you may actually blow the retainer and this side of the check valve out. When that happens, you don't realize the check ball may also come out all at the same time, and you'll find these 2 pieces, not knowing there's a check ball there. I've actually had a lot of techs install this without the check ball, and of course at that point we're going to have a problem with the C3 clutch. There'll be a major leak there. Here's some of the check ball locations. These are all rubber check balls, same diameter, about 216 thousandths. They're a dark blue, almost black in color. And on some of the models that have the 960E, there may not be a check ball at this location. Always check the plate by putting the plate down over it. If there's no hole for the check ball, it doesn't need to be there. One of the things I want to point out here, if we're looking at the exploded view, this is the accumulator regulator adjustable sleeve. As you can see, it has steps to it. If we have to take this out of the valve body to clean it and check it, we want to make sure we mark where the pin went. You don't want to put this back in the wrong location. It'll affect the shift feel. Here's some more check ball locations here. As you can see, there's 2 locations on the A960 with some models may not have a check ball located there. This is the C1 accumulator valve. This should be removed during overhaul. You need to take this out and check the bore. Make sure there's no scoring marks on the piston itself. And then this is the line pressure blow-off ball. This check ball is a little bit larger. It's 315 thousandths. The ball goes down inside the hole first with the spring on top. Here are your accumulator identification and locations. The spring dimensions and colors may vary from model. They'll be model specific. One of the things I want to point out, this gets lost quite often, this is the actual drain back valve. It goes down inside the case with the spring first, so the valve body would be showing as you see here. This is the F3 sprag, or the low reverse sprag. It freewheels clockwise and locks counterclockwise while holding the outer race. Now if this is installed incorrectly, you'll have no forward gear and drive. You'd have to go to manual low to get drive. And then obviously at that point you would have a bind up on the 1-2 shift, that's when the sprag should be freewheeling. This is the F1 sprag. You first have to install the third brake cylinder and the snap ring in the case. When you do that, make sure you check the apply hole so that the cylinder 3 aligns the oil pressure apply hole with the hole in the transmission case. You have to make sure that that lines up correctly. When installing the number 3 sprag, make sure that all 4 of the tabs are facing up. And same as the other sprag, this one rotates clockwise and locks counterclockwise. Install the number 2 sprag that has thrust washers, make sure they're in place. If you hold on to that sun gear, you can see that the sprag also rotates clockwise. If this is installed wrong, you'll have no second gear, and obviously you'll have a bind up on the 2-3 shift. And then the F4 sprag, the last one. This one can easily be checked by holding on to the C4 clutch hub. And as you can see, if you're holding it upright, that the sprag will turn clockwise, and then it locks counterclockwise by turning the C1 clutch hub. This is the C1 clutch clearances, the C1 and C4 drum. C1 clutch clearance is 22 to 34 thousandths, while the C4 clutch clearance is around 12 to 24 thousandths. Now these clutch clearances may vary from make and model. Always check your factory information to make sure that we have the right clearance. As you can see, we have 2 molded pistons here, both the C1 and the C4. These should be changed during overhaul. This is the layout of how the pistons go down into the drum. As you can see, we have the C4 clutch or coat clutch. It's installed first, and then we have the C1 or forward clutch installed on top of that one. One of the things I want to mention here about the C2, C3 clutch drum assembly, the notches that are on the C3 drum have to line up with the tabs. The notches on the C2 drum rather have to line up with the tabs on the C3 clutch drum. And as you can see, these are the tabs that are on the C3 clutch drum, and these are the notch cutouts for the drum to slide down past it. We don't want to align it here. We want to try to keep it aligned with these notches. The clearance on these clutches are 20 to 30 thousandths on both. Again, make sure by checking with factory information for the model you're working with. Now, as well as the notches on the C3 cushion plate also line up with the tabs on the C3 drum. This is in order to get the snap ring down in there to make sure that it fits. And you can see these notches are what I'm talking about right here. Once that's in place, we'll put the snap ring on. Now we can flip the drum over, and this is the C3 piston. Basically what happens is it'll pull the drum upward so that the cushion plate here will apply the clutch as the C1 clutch. Now this is very similar to a A760E. They work the same in the same manner. As far as the C2 drum that has an aluminum piston, the only molded piston is the balance piston. It has a molded balance piston, but the other piston is just aluminum. This applies like any normal clutch. So the C2 clutch applies normally with the piston coming up. The C3 clutch applies by the drum being pulled down towards the C3 piston. Sometimes there's some confusion after the unit's been taken apart as far as how it goes back together with these bearings and spacers on the output shaft. When you remove the tail housing, always make sure that all your shims are located on the shaft, and maybe one of them might be still inside the tail housing. Make sure that we don't lose those. These shims have to go back in place. So the spacer goes on first, then whatever shims that you have. Now once we get to this snap ring, we take the snap ring off. You'll see that we have a thick race, we have a thrust bearing, and then we have a thinner race. This thinner race will actually have a lip on it. The lip faces towards the case. Here's some pump air checks for you if you set the drums down on the support. check some of these clutch packs. We want to make sure we regulate our air pressure to 30 psi. I always suggest that for any air checks. You also have in your handout the case air checks. One of the things I want to mention here is we have 3 seals that go on the case before the valve body is bolted down. Make sure that these are replaced during overhaul. Otherwise, we'll have a leak in any one of those clutches. Now, according to Toyota, you need a special adapter to check the line pressure. Obviously, we can either make up our own tool, or if your gauge hose reaches in there without any problems, you don't need the adapter. We're giving you the baseline pressure in drive and in idle is 50 to 60, in reverse 7 to 80, and then in stall speed on drive is 180 to 195, where the stall speed in reverse is 210 to 235. Now, if you have a capable scan tool or laptop software that you can go in with bidirectional controls, controlling the line pressure, you can actually watch the gauge and see if everything's working properly. The transmission fluid service and fill procedure, there's a way of doing it without the scan tool to monitor the trans temp. Like anything else, these have a overfill tube that has to be checked at a certain temperature. So if you don't have a scan tool for it, this is the way to bypass it. Just put a jumper on pins 4 and 13 of the diagnostic link connector here. You put a jumper there. And then we're going to start the vehicle up, move the shifter from neutral to drive every 1.5 seconds to 6 for about 6 seconds. We'll make sure we have all the air out of the unit. Now, once we put this jumper in, the D shift indicator on the dash comes on for like 2 seconds. This indicates that the fluid temperature check mode has been activated and started. Now, the shift indicator will come back on again when the fluid reaches 115 degrees. That's where you top off your fluid at that point. Now, the indicator will blink if it exceeds 133. We don't want it to go that far. We want to have fluid ready to be checked so that as soon as the indicator light comes back on the second time, that's when it's topped off and we can go ahead and put our plugs back into the pan. And you can see we have the rest of the step-by-step procedure to check the fluid, refilling the fluid, and this is whether you are changing just the pan or doing a whole overhaul on it. The procedure is the same. We do suggest that you use the WS fluid, the world standard from Toyota, because we've had so many problems and complaints on the tech lines with these not shifting right because they used a different fluid. Now here's where one of the fill plugs is located on the left side of the trans, right by the linkage. There's our overflow plug. As you can see, when it gets to a certain temperature, that's when we want the oil to, when it stops dripping out at that point. Now, the fill plug, the large one that you see here on the left, that's located behind this cover. It's only 2 bolts. You'll have to remove that cover to get to it. There's another fill plug towards the back, but as you can see, it's quite smaller. It's a little more difficult to try to fill it through that one. It's much easier to use the larger one in the front. Here's the pan comparisons of the 3 units. As you can see, the AB60 is much larger than the other 2. The 760 and 960 are pretty close in size, but the bolt pattern is different. So those 2 are not interchangeable. Here's what the fill level looks like on the inside of the pan on the AB60 and the 760. The 760 and 960 are very similar. Don't forget we have a seal that goes on the drain plugs. We want to make sure that we replace that. The filter and rubber pan gas is going to vary from unit to unit. Make sure we're using the correct filter for the unit that we're working on. Common problems. The first thing that comes to mind will be the sealing ring. That's on everyone's list of problems with this transmission. Now, which to use, the OE, the aftermarket, or simply reuse the original rings? Now, that has to do with the builder. That's builder's choice. Uh, One of the things I do want to mention, even if you're reusing the original rings, be very careful installing the rings on the shafts. If they become distorted, they have very poor memory. They don't conform back to the original shape very well. This has been a common problem with many other units. The one most talked about lately is the RE5, RO5A. It's the same thing. They're made from that same type of a vest bell material. So because of that poor memory, if you distort the rings, they will leak. So if you do a comparison from the OE ring to the aftermarket, what we're showing you here is the OE. If you cut the ring, you'll see that it's actually tapered. So the inside diameter is slightly smaller than the outside. So if you think about it, as this ring wears, it'll be actually less sealing area. The aftermarket rings are a straight cut. This is designed to be able to spin easier in the groove. A lot of times we've had guys air checking the unit. They have new OE rings, or they have new aftermarket rings. It's not air checking correctly. They put the original ring on and the air checks fine. Most of the time, or a lot of times I've seen that happen, it's because if you look inside the groove, it may be distorted. There may actually be a step cut into the groove. So of course the original ring is worn in with that step, so it may actually seal better. Sometimes these grooves are very, very difficult to see. I've actually been in shops and ran into that problem. So be careful which rings you use. Make sure they air check fine. Again, just be careful putting them on so we don't distort them. Second biggest problem that we have on the tech line with this is actually the fluid issue. What happens is a lot of shops will have a synthetic fluid they use across the board, and they may have even used it on one of these units and not had a problem. This is similar to the ZF, the Mercedes, Hondas. They should have a specified fluid. The biggest complaint we get is the transmission is running hot. We go through the valve body, the solenoids. We don't find anything wrong with the cooling system. It's the same oil we've used on other units. On every single one of those calls, when we had them remove that oil and put in the WS oil, it's fixed every one of those complaints for running hot. And we couldn't find anything else wrong with the vehicle. As you can see by this chart, both fluids, when they get hot, have the same viscosity, but this fluid is actually designed to have a lower viscosity to put less drag on the transmission, and it's actually designed for this transmission. I suggest using it. If whatever you're using is working for you, that's fine, but if you do run into a problem, try using the OE fluid. Third most common complaint will be electrical connections, especially where the case connector or the internal harness fails. Those are the most common problems we have when it comes to solenoid codes. These solenoids will actually fail mechanically before we've seen any electrical issues with them other than connections and wiring. As you can see here, there's some tools you can purchase to repair these solenoids yourself. And then, of course, there's valve body wear. The three most common failures in any valve body in today's market would be the solenoid modulating valves. GM refers to this valve as actuator feed limit. These valves regulate the oil to all the solenoids, so they work quite often. They're very busy solenoids. Second most common would be the TCC reg valves on any transmission. And then third would be the pressure regulator valves. Every so often on the tech line, we have a tech calling that has a problem with a slight TCC shutter, maybe between 30 to 50 at light throttle, or maybe even a slight shift flare at light throttle. Valve body checks out fine. There's nothing wrong with the solenoids. All the load sensors on the vehicle are working correctly. We've actually had them go in on the pressure regulator adjustment sleeve and just turn it up to one higher notch. So basically it came in this way. You can see we had it marked. We'll turn it in so it puts a little bit more tension, increases the pressure slightly, and that's actually fixed some vehicles. Now, would I say this is a standard rebuild procedure? I may not. I may not want to do that and then end up with some kind of shift complaints where they're being too firm or downshift clamps or anything like that. So I suggest that we may want to do this as a try if everything else seems to be okay when you do run into that problem. This is another one that's been coming across the tech line quite often. Seems that some of these 04 to 05 Lexus vehicles, that's the IS430, it has a 4.3 liter engine and the 760 transmission. The complaint's been a harsh coast down or a harsh uh, downshift complaint. You know, it doesn't mean that we're saying that we've seen so many of these that every one of these computers are bad. That's not the case. Several of them have been fixed by putting a new ECU in with the latest reflash. There's no TSP from Toyota or anyone for this. So before you condemn any computer, you have to make sure we check. We don't have an engine idle issue, throttle's not sticking, causing a harsher downshift. All the load sensors on the engine are working fine. And before you ever change a computer, make sure that all the inputs, especially the powers and grounds to the ECU, are all good before you replace it. Again, we're not saying that this is something that every one of these gets an ECU. No, in some cases we have seen some only fixed by a new computer. And that about does it for today's presentation. I want to thank you all for attending. If you have any questions, please go ahead and text them to me now.